polynomial division today, and we're going to look at just regular polynomial long division today. Tomorrow I'll show you a shortcut for certain types of problems. So let's review really quick, how do we just do regular long division? Because if we go through one practice problem with numbers, it kind of sets you up to be ready to do this with polynomials. So if I were to write this out as a quotient, what's the number that goes, what's the dividend? What's the number that goes inside the division symbol? 178, yeah. Okay, and the 3 goes out front, right? And then what's the game we play here? So we ask ourselves, does 3 go into 1? No. So then we scoot over to the next digit. Does it go into 17? How many times? 5. Okay, it goes in 5 times. What do we do then? Okay, we multiply and we subtract. So 3 times 15, or 5 times 3 is 15, and I'm going to subtract that whole thing, right? Okay, and now notice what happens. When I subtract, at least one of the digits disappears. Every time we do this, at least one of the digits disappears from the dividend, and we start whittling that thing down gradually, don't we? Right? Okay, so then we get what left over? Okay, and we bring down the 8. Okay, and we go again. 5 goes in, or 3 goes into 28 9 times. What do I do? Multiply and subtract. Okay, and then what do I end up with? I end up with a remainder of 1, right? And I know I'm done now because 3 won't divide into that anymore. So that's my remainder. A lot of times, like back in, I don't know, elementary school, and you guys used to do stuff like this. Like you'd say the answer is 59R1. Do you remember that? That's dorky. We don't do that. What doesn't even mean anything, right? So what we do instead is that, what does that R1 mean? It means the remainder is what remains over the denominator. Yeah, it's what remains over the denominator, right? That's what you always remember. The word remainder means what remains over the denominator. So our answer ends up being, look, we get this integer part, 59, and then we get this remainder part. We still have our 3 on the bottom, but our remainder is a 1. So we get 59 and 1/3, which is the same thing, by the way. That's the way we write a mixed number. That's the same thing as saying 59 plus 1/3, isn't it? 1/3 more than 59? Okay, right? That all seems, you guys remember doing that stuff, right? Okay, well, this is the very same process we follow with division. Okay, now this is an easy one though. When I divide a polynomial by a monomial, we don't have to do anything fancy at all. What could we do here without, you guys could already do this. Yeah, I split it up and simplify each term. That's something you could have done before today. I didn't even need to, you already know that. I don't have to show you anything. So if I split this denominator up then, I'm going to split it up into all 3 of those fractions, then I'm going to get this is equal to 4x to the 6th divided by my common denominator plus 24x to the 5th divided by my common denominator minus 32x squared divided by my common denominator of negative 4x to the 4th, right? And then we can just simplify each one of those. So what do I get from my first term here? 4 over negative 4 is negative 1. So I'll put a negative out front. X to the 6th over x to the 4th, x squared. There's my first term, okay? Plus 24 divided by negative 4, negative 6. X to the 5th over x to the 4th. Okay. Minus 32 over minus 4. 8. Okay, so plus 8 x squared over x to the fourth. X to the negative 2, which means it's an x squared where? Over x squared. There you go. Right? And how could we do that? We could do this the way I showed you guys. If I'm dividing like bases, I keep the base where it has the most power and subtract the other exponent. So I could leave it on the bottom as x to the 4 minus 2. Okay? Make sense? Okay, done deal. Piece of cake. That stuff you already know. Okay, what about this though? This is a little different. Now, this is where we have to go back to that long division example we just did. So you guys already told me that what's on top goes in the dividend, right? That goes inside. And what's on the bottom goes out front. Now notice I did something important here. When you write the polynomial out inside the division bar, you have to include a column for every power of x. If you don't do that, you are going to get it wrong. 100% guaranteed. It's not going to work. You always have to carve out, and this should look familiar, right? We've done some things sort of like this before. You got to leave that column for the 0 x there because the x term is skipped. Okay, what goes out front is then our denominator. X squared minus 1. Do I have to include a 0x there? No, I don't. Only inside. That's the only place I have to. Okay, now this is a little bit different than what we did with numbers. When we did the example with numbers, we asked how many times does the 3 go into the first number that it goes into? It goes into 17, right? It doesn't go into the whole thing. We're just dividing 3 into the 17 part. We're going to do something like that here. Only when we're dividing a polynomial into a polynomial, all we care about are the leading terms, okay? So we're going to ask, how many times does the leading term outside divide into the leading term inside? And we can always find out by just writing out that quotient. First term inside divided by first term outside. What is 3x cubed divided by x squared? 3x. Okay, good. So then our first term in our answer is going to be 3x. Okay, what did we do when we got a number up top? We multiplied, didn't we? Right? We multiplied that number and subtracted. We're going to do the same thing here. I'm going to multiply, instead of a number, I have a term. I'm going to multiply that term by what's out front and subtract. Now, do you see why we need those columns? We need to be able to subtract stuff vertically, right? So we need to have a column for every power of x. So 3x times x squared is going to give us, let's see, that's going to give us 3x cubed, right? And so those are going to cancel like they should. 3x times negative 1 is negative 3x. Where does that one go? Where do I line up my minus 3x? It's going to go in the x column, so right there. Okay, here's the tricky part. Here's the tricky part. This is where people are likely to make a mistake. We're going to put this thing in brackets or parentheses and put a minus sign out front because we're subtracting vertically. When we do long division, we always subtract vertically. Okay, so then what's going to happen here? 3x cubed minus 3x cubed, 0. They cancel, right? Okay. What about here? What do I do with this negative 8x squared term, do you suppose? I'm going to bring it down. Yep, because I'm subtracting 0. So I get a negative 8x squared. Now, you got to be careful with this one. What's going to go there? What's it going to be? Minus 3x. Let's see. 0x minus negative 3x is 3x, right? You don't just subtract vertically. You have to remember, you don't just add vertically. You have to remember that you are subtracting vertically. So 0 minus negative 3x is 0 plus 3x. So I get a 3x. And then finally, what happens over here? Bring it down. Okay? Give me thumbs on that. Does that make sense? That first step? Okay? Questions? Questions? Okay. Question? Yes, sir. Because I'm subtracting vertically, so I'm subtracting the bottom x term from the top x term. There is no x term in that row. So I'm just saying negative 8x squared minus 0x squared. Minus 0 just leaves me that negative 8x squared, right? So anytime there's nothing to subtract below a term, you just bring it straight down, which is the same thing that we did right there. We brought that 8 down. Okay? Yes, sir.
Can you go back to it? So are we just, why is it subtracting 3x? Because the 3x times the negative 1.
Yeah, because I distributed the 3x up here to my x squared minus 1. 3x times x squared is 3x cubed, so that goes in that column. 3x times negative 1 is negative 3x, so it goes in the x column.
Where did that come from then? Like
X squared minus 1?
no, the 3x.
Because we asked, what is the quotient of if I divide the leading term inside by the leading term outside? So 3x cubed, okay, right? Okay, so now we finished round 1, and then we just reset and start again, right? So what do you think we do next? Oh, negative 8x squared divided by x squared. We do the same thing again, right? So then we get negative 8x squared divided by x squared is just giving us negative 8, right? Okay, so we distribute a negative 8 all the way through. And what's that give us? If I distribute negative 8, negative 8 times x squared is negative 8x squared. Negative 8 times negative 1 is plus 8. Okay, now what? What do I do? Subtract, which means I'm going to put a negative sign out front and put the whole thing in parentheses, right? So what do I get here? Cancel. Good. What do I do here? What do I do here? Straight down. Yep. How about here? What am I going to get? 3. Good. 11 minus 8 is 3. Okay, now what? Yes.
I have a question.
Yep.
So on there, you're putting the numbers and then you're skipping some. Is it just alternating, like you always have the first ones that you alternate, or how are you?
You mean because I skipped here, you mean?
Yeah.
Okay, the reason that happened was because we had no x term up here. That's why. It doesn't always happen that way. We'll look at some examples where it doesn't do that too. You see, because every time I distribute, I'm gonna skip powers, so I'm gonna kind of skip rows or columns.
There's an x squared on the first step.
In the one that you call the like term, you can't subtract an x squared from an x.
Right, you see what I'm saying? Like when we distributed the 3x up here, we got 3x cubed minus 3x. Well, I want to combine like terms when I subtract these things. That's why we line them up vertically. Okay, that's why sometimes we skip columns. Okay, now what? Okay, can I go again? How many times what is 3x divided by x squared? Yeah, okay, so now this time it's different, isn't it? This time we're done, right? Because the x squared does not divide evenly into x, right? So that becomes our remainder. Okay, that's our remainder. As soon as we get to a point where the power of x is smaller in what we get after we subtract than what we have up here, then it's our remainder. Now in the last step, they were equal, which is fine, right? Negative 8x squared, or sorry, negative 8x squared divided by x squared. They still divide in, the x's cancel. But as soon as I get down to x to the 1 here, I'm done because I'm trying to divide x to the 2 into that, right? So this becomes our remainder, okay? And then what do you suppose the answer is going to be? What is this quotient?
3x minus 8 or 3x plus 3.
Okay, so it's okay, good. So here's the polynomial part, right? We get the 3x minus 8 There's the regular polynomial part plus the remainder part. Okay, what goes on top? 3x plus 3. What goes on the bottom? X squared minus 1. You betcha. That's what the denominator stays the same. And that's our answer. Okay? Make sense? Okay. Let me see something here. Yeah, let's go through. You want to go through one more of these together? Okay, and then I'll let you guys try one on your own, and that'll be it for today. How about? Okay. All right. So this guy, yikes. What goes inside? Okay. 4x to the fourth plus. Keep going. Tell me what to put.
X cubed.
Plus.
6x squared.
Okay, am I done? Okay, good. Plus 0x plus 0. Yep, I have to have a column for every power all the way down through the constant. Okay. What goes out front? That whole thing, right? Yeah. So we get, yikes, we get 4x cubed plus x squared plus 3x plus 5. Okay, so first things first. What's our first term? 4x to the fourth divided by 4x cubed, right? Okay. What is that? X. And you could probably just get that by asking yourself, 4x cubed times what is 4x to the fourth? X, right? See what I'm saying? You don't necessarily have to write that quotient out. You can. So we get x. What do I do with the x? Okay, good. So we're going to multiply. We're going to distribute that all the way through. So what's that going to give me? Okay, now notice that those are always the same, aren't they? They have to be. When I subtract, that leading term is always going to cancel. That's the point of this. That's how we get through the problem. Every time we do this, we just whittle it down more and more, right? Okay, what's the next one? What's the next one? 3x squared, okay, good. And that's it, right? So now I'm going to subtract all that stuff. Oh, whoops, I forgot. Yeah, there's more. You're right, there's more. Whoops. Yep, so what's the other? X times 5 is? And that's it. There we go. Now we're good, okay? All right, so now when we subtract, those guys go away. Those guys go away. 6x squared minus 3x squared gives me 0 minus 5x gives me negative 5x. 0 minus 0 is, so I can forget that one, right? Okay, can I keep going? How come? That's only an x squared, and that's an x cubed. I'm done. So this is my remainder. How about that? That ended up being a pretty quick one, right? So the final answer then, my quotient is equal to what? X plus
3x squared minus 5x.
divided by,
The original.
yeah, the original denominator. There you go. Whoops. Okay. Does that make sense? Okay. You want to try one? On the board? Go. There it is. Go. Okay, so this is what you guys all got, correct?
Yeah.
Right? Okay, this took a while, didn't it? That was kind of a pain. Okay, I'm going to show you guys tomorrow a way you can do this problem. This took probably an average of 12 and a half minutes, maybe. I'm going to show you a way you can do that, and I'm going to estimate 1 minute and 7 seconds. Done. Give or take.
Is it putting the X's to like?
No, I'll show you. It's called synthetic division. I'm going to show you guys a trick, but it only works in certain situations. So you got to be careful when you use it. But this one is tailor-made for it. This one right there, it would not work. But that one, it would, and it would be great. So good stuff coming tomorrow.